Yes, have you started the stream? Okay. Yes, Mithun, have you come to the stream? Okay. Pair of linear equations in two variables that we will see today, no? Can you see it written on the board? Okay. Everything clear? Clear no? Video? Fine. So, the lesson is pair of linear equations in two variables. Okay. So linear equation, just before this we have studied no quadratic equation. So all those are actually algebraic expression made equal to some other values. All those were algebraic equation only, no, in the form of x, y, constant, operators, plus, minus, multiplication, division. So linear equation, can you define linear equation? We studied something. What do you understand from linear equation? The power, that is degree, don't say power, okay? Degree. Power means it can be any, but degree means the highest power, okay? Degree means the highest power. So in the quadratic equation we had the degree 2. In the linear equation we will be having the degree, yes, degree 1. So if you try to understand little about the linear equation, if we write here 3x plus 5 is equal to 2. Suppose I write this. What have I written here? 3x plus 5 is equal to 2. We can call it a linear equation or not? If any problem in video clarity or any buffering problem, okay, you just inform me, fine? Because I am using a different net, okay, different operator net, so I want to know whether the clarity is same or not, okay, with the previous one. Fine? So if any difference you observe, you just inform me, okay? Fine. So 3x plus 5 is equal to 2 is the linear equation, because the degree of the variable present here, the highest degree is 1, that's why it's a linear equation, okay? Now we have something called as solution of any equation. We saw quadratic equation solution, no? Solution of quadratic equation means that value of the variable present there which will satisfy the equation, which when substituted will satisfy the equation. No. So just like that, solution here means what? The value of x which when substituted here will satisfy the equation. Satisfying the equation means LHS will become equal to RHS. Okay. So let us try to solve and find the solution for this. Okay, how many variables are present here? How many variables? X type, Y type, Z type. How many variables present here? One type only, no? X, no? Yes. So we can call it linear equation in one variable. Can we call it? Now let us try to solve it. So 3x is equal to what will happen? 2 minus 5, no? Then x will be equal to how much? Minus 3 by 3, that is x is equal to minus 1, no? So if you substitute here x is equal to minus 1, what will happen? 3 into minus 1 plus 5, which implies how much? Minus 3 plus 5, that is equal to 2. And so this value will give us 2, and which is equal to RHS. Means the value of x which is minus 1 is satisfying this equation. Okay, understanding that language? Yes, the value of x minus 1 is satisfying the equation here, means when substituted here is making LHS equal to RHS. Clear? So this is called solution of equation, whether linear, quadratic we saw the three ways, no? Quadratic formula, factorization, and by completing square method. Fine. So here also we will see some of the types of solution. But generally we are starting from the basic, that what actually the linear equation means. So this is linear equation in one variable. Clear? Now solution we got. Okay. Now let us little discuss about what this equation, this 3x plus 5. 3x plus 5 is equal to 2 will actually represent on the graph. This is the Cartesian plane that we use to locate everything on this, no? All the equations, everything. So what this equation will represent here in the Cartesian plane? Cartesian plane, yes, Cartesian plane. It will represent actually a straight line. No? It will represent a straight line. Okay. So let me tell you, it will represent actually this one. Okay. So this is 3x plus 5. Okay, this line. So this is the linear equation in one variable. Okay, and this is actually representing a straight line. Okay, so when we will have linear equation in one variable, okay, the representational line on the graph will always be either parallel or perpendicular to any of the axes, x-axis or y-axis, either parallel or perpendicular. So see this line 3x plus 5 is equal to 2, this is straight line is parallel to y-axis, perpendicular to x-axis. If it is perpendicular to parallel to y-axis, it will be perpendicular to x-axis. Okay, or if it will be, if any other line is parallel to x-axis, it will be perpendicular to y-axis. No, it's a common thing, normal, that since these two x-axis and the y-axis are perpendicular, that's why if any line is parallel to one axis, it will be perpendicular to other. So what I am telling, that the linear equation in one variable, if you try to represent on the graph, you will always get a line parallel to any of the axis or perpendicular to any of the axis. Okay, we will not get any oblique line like this, oblique line making some different angles with the axis. We will not get that. Okay, fine. Now, so we saw here no solution x is equal to -1 is the solution for this line, for this equation. No. So see, you remember that polynomial for any curve, the zeros for that polynomial on the graph, just seeing the graph, how we were finding, seeing where that graph is getting intersected by the x-axis, no? So just like this, see, this is also one of the graph. It is a straight line graph. 3x plus 5 is equal to 2. It is getting intersected by the x-axis at one point or not? And which point? -1. So -1 is the solution. Understanding? Can you relate that and understand? So all are interrelated. Okay, we cannot see this is quite completely different or not. No. So that's why understanding of each and every topic for you is important for the board examination. Okay, for the board students. So this is x is equal to -1 is the solution. We can see here on the graph also. Yes, here at one point it is getting intersected by the x-axis, and that point is only the coordinate of that point is only the solution, x coordinate. Okay, this is clear now. So we discussed here what linear equation in one variable. Okay. Now little we will see about linear equation in two variable first, and then we will go in deep. The basic first, let us understand. Any other example? Suppose here 3x plus 5y plus 2 is equal to 7. Okay, this is the equation. Now for the linear equation in one variable, for a single equation, single solution we had. No? We had a single solution. Now let us discuss about a single variable, linear equation in two variable and a single equation. 3x plus 5y plus 2 is equal to 7. So we can see here the maximum power of the variable present here is 1. So this is linear. Okay. So this is linear. Are you listening here? No, please concentrate, focus here only. Okay. So the maximum power here either of x or y, we can see here 1. That's why it is called linear equation. Okay. And since this equation is in two variables, x and y both, so it is called linear equation in two variables. Here it had only one variable, here two variables. Now, so this is called as linear equation in two variable. Now, tell me what do you understand from the solution if we ask what is the solution of this linear equation in two variable, this single equation. So what can be the solution? Those values of x and y, which when substituted here satisfies the equation, can be called as the solution of this equation. No? So all the values of x and y when substituted here, if it is making LHS equal to RHS, we will say those are the solutions. Okay, and we have been right now given, suppose single variable, one variable only. One equation. Sorry, we have been only given one equation, and linear equation in two variables. So what can be the solutions? Can you find the sum of the solutions, or one solution, two solutions? How many solutions it can have? How? That if we will try to make a box like this, x and y, no, and if we try to find here x, then what will happen? 7 minus 2, 5. 5 minus 5y by 3. Isn't it? From this equation we can get x is equal to this much. No? And if we will keep what? Y as 1, If you substitute y as 1, then what will happen? 5 into 1, 5. 5 minus 5, then 0. 0 by 3, 0. So x we will get 0. If you substitute here y any other value, how much? Say anything. Y minus 1 or 0. Anything. 3. Y3. If you will put y3 here, then it becomes 15. Minus 15. No. And then 5 minus 15 means minus 10 by 3. So x we will get minus 10 by 3. If we put y0, then this will make 0. So 5 minus 0 is 5 and 5 by 3. So we will get how much? 5 by 3. No. So like this we can go on finding. It will never stop. Okay? It will never stop. Clear? So if a single equation is given to us, and that is the linear equation in two variable, then we can have infinite number of solutions. Means infinite number of x and y value which when substituted here will make LHS equal to RHS. Okay. Now coming to, this is clear. Now coming to the representational part, that what this will represent. What this will represent on the graph. Yes. What happened? Okay. So what this will represent on the graph? A straight line or some other curve? What? Since it is linear, since the degree is 1 only, it will represent a straight line only. Okay? It will represent a straight line only. But here since two variable, no, we can get an oblique line also. Any type of line we can get. Okay? So how we can get that line? We have to substitute, we have to plot, we have to mark the points. What? 0, 1, first point, x, y, no. Then second point, 5 by 3, 0, x, y. Then minus 10 by 3, 3. This third, and then dot 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 like that. So any 3 points if you will present here, x coordinate, y coordinate, you know how to locate the points, no? So if we get here the points, then joining the 3 points we will get our straight line. Okay? So we must avoid taking only 2. We should take what? 3 points. Taking 3 points will clarify that we are not doing anything wrong. Okay? Because any 2 points you take, it will join, we can get a straight line. But for the 3 points to be in a straight line, it's important that the solution must be correct. And that's why we must take 3 points for locating any type of a straight line. Further we will be needing this. Okay? That's why we are discussing here. Okay, Mithun? So this is clear, no? That what it will represent? It will represent a straight line only, but it's not needed that it will be parallel or perpendicular. It can be anywhere, oblique line. And how can we represent this? By plotting the 3 points. How can we plot the points? How can we get the points value? Like this. So this is clear, linear equation in one variable. So we discussed now linear equation in one variable, a single equation, linear equation in two variable, a single equation. Fine. Now we will come to pair of linear equation. Pair of linear equation means when the linear equation in two variable given, how many? 2. Linear equation in two variable. This is linear equation in two variable. But right now, till now, we have not discussed about the pair of linear equations, means two equations. No, we have only discussed about a single equation. Okay. Now let us discuss something about linear equation in two variable. Okay. This is clear. Shall I rub this? Okay. How is the clarity so far? It's okay, or something less than the previous? Working normally, no? Or something different? What is happening? Yes, means a smooth flow is not there of the action, that you are telling. Means if I am rubbing like this, so a smooth flow, like normally it is not showing, it's showing like it's stopping and doing. No, are you sure? What I am telling is, that only you are telling. Okay, and what about lagging? Means, is there any lagging of the voice and action right now? Okay, lagging is not there. Just action is fluctuating, no, like that, not a smooth flow. Okay. Okay, I will see in the video from next class, that old one only. Fine. So now pair of linear equation in two variable. Fine. So we have in general a1x plus b1y plus c1 is equal to 0. Okay, general representation for linear equation in two variable. Okay, and the second one is a2x plus b2y plus c2 is equal to 0. Fine. So this is the general representation for the linear equation, second equation. So a1, b1, c1, a2, b2, c2 are actually the coefficients. A1 is the coefficient of the x of the first equation, b1 of y, and c1 is the constant of the first equation. Of the second equation we are representing it by 2, 2, 2. Okay. So if you want to represent this alone on the graph, what it will represent? A straight line, any line, oblique, parallel, does not matter. It will represent a straight line anywhere, no? Just the same, we will try to get x and y points, 3 points, and then we will plot it, we will get a straight line, we will join them, we will get a straight line. Just like that, the second also we can get a straight line or not? Second also same thing, yes. So like that only we will get the second line also, okay? So graph is easy, we have seen. Now the first is what? Yes. What do you mean about the solution of here? Pair. Solution of the linear equation in two variables. Pair of linear equation in two variables. This is one pair. This is one pair of linear equation in two variables. So what do we mean by solution of that? Solution of these two is so separately if we will find, then we will get thousands of x and y value in this, and thousands of x and y value, and millions and infinite number in this. So what do we actually mean? Pair of linear equation. Now this is as a whole a single pair. No, together. They are not together. They are not now separate. Okay. So together we have to discuss. So what do we mean by solution of the pair of linear equation in two variables? Solution. What do we mean by solution? See, in the quadratic we had, yes, the value of the variable. No? In the quadratic we had the value of the variable. No? Which when substituted there satisfies the equation. No? So just like that here also same thing. What? The value of the variable x and y, which when substituted satisfy both the equation. Satisfies both the equation, means a single variable value of x, suppose x, and a single value y you got from somewhere. Now what you are doing, you are substituting these values here in the first equation. Okay, you are substituting this x and y value in the first equation. You are saying it is satisfying, means LHS is equal to RHS. The same x and y value, you are substituting in the second equation. You are saying that this is also getting satisfied, means here also LHS is coming equal to RHS. Then only we can say this x comma y is the solution of this pair of linear equation in two variable. Okay, because if single equation we will take and we will try to find so many solutions, we will get infinite number of solutions. Okay, so what do you mean by solution for of the pair of linear equation? Those values of x and y which satisfies both the equation together. Okay, which satisfies both the equation, that only means the solution. So here we will get three types of solutions. What we will get? We will get here three types of solutions. Yes. So let us see on the graph. Okay, let us see on the graph. See how this pair of linear equations can be represented on the graph. How this pair of linear equations can be represented. See. Okay. So either we can have the two equations. The two equations mean the two straight lines. No. So either we can have like this, or we can have like this. Okay, or we can have this is a straight line. So these two only, the three possibilities have been shown here. Okay, when we will represent these two on the graph, the three possibilities can come. The first possibility, forget about this and this. The first possibility is here. It may be intersecting. The two lines may be, yes Mithun? The two lines may be intersecting each other. Okay, maybe intersecting each other at some common point. This is the common point for both of them. This point is lying on this line also and this line also. Okay, and we know each and every point on the Cartesian plane has x coordinate and y coordinate. We know that or not? So this point coordinates, the x coordinate and the y coordinate, will actually be the solution for this pair of linear equations. Okay, x comma y, x coordinate we can observe from here and y coordinate we can observe from here, and that will be the solution of this linear equation in two variables. Okay, fine. So in one of the possibility, while presenting it on the graph, we may get intersecting lines, and if we get intersecting lines, then we will have only one common point which will lie on both the lines, and that common point coordinates will actually be the solution which will satisfy both the equation. Okay, so from the graph we can get the solution like this, and here we have to solve it, and that how to solve we will see. Okay, we have three ways, like quadratic we have three different ways that we will learn later, but from the graph you understand first. Okay, okay, one little discussion before this. This is the Cartesian plane. Okay, suppose we have any line like this, suppose. Okay, straight line, and we have some ax plus by plus c is equal to 0. Okay, this is the straight line equation. Okay. Now my question is, not question actually, understand, each and every point on the straight line, each and every point on the straight line, how many points, from how many points does this straight line is made up of? How many points? Infinite number of points. Okay, infinite number of points. And I just now I told that each and every point on the Cartesian plane, anywhere, if each and every point on the Cartesian plane has the coordinates x coordinate and y coordinate, no? So we have to understand one thing here, that since on this straight line, each and every point coordinates is actually the solution for this equation, ax plus by plus c is equal to 0. Okay, means you take any point on this line, find its x coordinate and y coordinate. Okay, find its x coordinate and y coordinate, get the value of that x and y, and try to substitute here. You will see it will satisfy the equation. Any point you take and find its x coordinates and y coordinate. Okay, find its x coordinate, y coordinate by drawing like this. You know how to find. Get its x coordinate, y coordinate, and try to substitute here. When you will substitute, you will see it will satisfy LHS and RHS. Okay, understanding? So any straight line, any point on any straight line are all the actual solutions if we talk about just a single line. Okay, so just like that we discussed here, that one of the possibility is intersecting lines. So intersecting, where they are intersecting? At this point. Are you listening? Yes. So okay, video is buffering. Okay, so we can see here they are intersecting at this point, no? So this point is common to both the straight lines or not? This point is lying on both the straight lines. It is lying on both the straight lines or not? When you are going through this line, you are coming across this dot, this point. When you are going through this line, you are coming across this. So this is common to both or not? And that is this is the reason only that the coordinates of this point x comma y will actually satisfy both the equations both the lines equation. Okay, this is the only reason. Since this point is lying on both the line, its coordinates x comma y will satisfy both the equations. Clear? So can you just briefly tell me what I just now I told? That if we have a straight line, we have infinite number of points. So what does this each point represents? What does it mean, each point? Each point coordinates is the solution of this straight line alone. Fine. So one of the possibility is when we will try to solve a pair of linear equations, means that value of x and y which will satisfy both the equations. When we will try to solve, we will get graphically three possibilities, in which the first possibility is this that we discussed. Okay, first possibility. What about the second possibility? Yes, what about the second possibility? Second possibility is here, that we may not get any common point. Means both the lines may be parallel. Here the lines are intersecting. Here the lines are intersecting. Here the lines are parallel. Okay. So parallel means, tell me how many solutions we will get here. How many solutions? How many intersecting points? Intersecting means intersecting each other, not any other axis, x axis, y axis. Intersecting each other, no. See, they are intersecting each other at one point. There are so many intersections. Here also one intersection, here also one intersection, but we are not bothering about that. When we talk about the solution of a pair of linear equations, solution of not a single but a pair of linear equations, then we talk about their intersecting lines in intersecting each other. So how many places they are intersecting each other? 0. So since they are not intersecting anywhere each other, means they do not have any common point, and since they do not have any common point, no value of x comma y can satisfy both at a single time, both, no. We can have infinite number of solutions for this line separately. We can have infinite number of solutions for this line separately. But when we talk about the pair of linear equations, solve it simultaneously together, solve it and get the solution, we won't be having any single x comma y value which will satisfy both the equations simultaneously at the same time. Okay? So this is the second possibility we may get, no? Second possibility. What is the third possibility? Third possibility is actually here, not single line. That the lines may coincide. The lines may coincide. The one line may be just over other. Okay? In that, how many solutions we can get? Many. If this is the line here, and another line if we are plotting the points, we are observing that both are coming over each other, exactly over each other. What does it mean? Each and every point on one line will be the solution of the other line. No, because each and every point on one line will also lie on the other line. Means they have infinite number of common points. They have infinite number of common points. So since they have infinite number of common points, they have infinite number of solutions also. Okay? Yes, Mithun? Is it clear? Little? Or buffering? What is happening? Okay. Fine. So let us see. These three things clear, no? That the three possibilities we can get while solving graphically, understanding graphically. Okay? Now, so for the, here we will get no solution. What we write here? No solution. Here we write intersecting, no, parallel lines. Parallel lines, no solution. Intersecting lines, how many solution? Only one solution. So this one solution has another name also. What it is called as? Unique solution. What it is called as? Unique solution. Okay? And for this, coincident lines, coincident lines, coincident lines, coinciding lines, right? How many solutions? Stopped, huh? Okay, so let me start the new stream. Okay, just stop it and go back.